Greetings, one and all, and welcome to this math lesson. Welcome to this math lesson. And the title of this math lesson is linear, at least one of the things that will be discussed in this math lesson is linear equations. Linear equations. All right, so let's consider the definition of linear equations. So let's go into the textbook and let's consider the definition of linear equations. So I'm grateful for the persons who have already come and are watching. And so one of the things that we're going to be looking at is linear equations, and I'm going to provide a definition for linear equations. All right, so notice the definition. It says a linear equation in one variable is equivalent to an equation of the form ax plus b equals 0, where a and b are real numbers and a is not equal to 0. Sometimes the linear equation is also called a first degree equation because the left side is a polynomial in x of degree 1. So notice the examples that were given, right? So we have 3x plus 12 equals 0. So let's consider that, right? So let's consider that example. So we have 3x plus 12 equals 0. And that is a linear equation. That was given as an example of a linear equation. This one right here, that is given above, is also a linear equation. 3x minus 5 equals 4. These two equations are called what? Linear equations. Now, why are they called linear equations, or what hint can we get in the definition in the name linear equations about how the graphs of these equations look? So let's consider how the graph of these equations look. So let's look at this equation 3x plus 12 equals 0, and let's see how the graph of the function look. And I'm not going to consider the 0 part. We're just going to consider the function y equals 3x plus 12. And let's see how that looks. And let's look also at y equals 3x minus 5, right? And let's see how that looks. And hopefully that can give you an understanding of why they are called linear equations. Okay, so we're going to go on a graphing calculator, and I'm going to show you how these graphs look. So notice, let's put it in. Y equals 3x plus 12. All right, so that's its graph, right? That's the graph of this function, right? And it's a linear function. All right, let's look at the other one that was given. We have y equals 3x minus 5. And again, notice the similarities between the two. What can you say about the red one and the blue one? What can you say about the red one and the blue one? Indeed, if you're thinking that, hey, Isaac, those both are lines, you're right. These two are both lines, right? So what can we say, right? What can we say about the graph? What can we say about the graph of linear functions, right? What can we say about the graph of linear functions? And indeed, the graph of a linear function, right? The graph of a linear function is indeed a line, all right? Is indeed a line, and that would make sense, right? It's kind of nice because notice in the name there's a hint. It says linear, and we could, in the word linear, we have the word what? Line. All right, so that could give you a hint. So when you hear linear equations, think lines, right? Now, indeed, the linear function, the graph of the linear function is the line. All right. Okay, so again, let's look at the definition. We're gonna discard that. So let's go back to the definition that we saw. So the definition says that an equation in one variable, a linear equation is an equation in one variable. So it's one variable. So we're not dealing with two variables. right? We're not dealing with three variables. We're dealing with one variable. One variable. And this linear equation is equivalent to an equation of this form. All right? And this is very important. Notice we have ax plus b equals 0. And that is the general form of a linear equation. Any linear equation in the world that you give me can be made to look like this, right? It can be made to look like ax plus b equals 0, all right? Regardless of what you give me, whatever linear equation you give me can be made to look like this, all right? So let me look at the feed. Oh, notice, and I should mention, that if you are watching this video and you have a math question from like a homework or whatever, you could please put it inside the chat and we'll see if we can answer the question. So feel free, even though I'm discussing linear equations, feel free to put your questions inside the comment section and we'll consider those questions. So let's go back to our discussion at hand. Okay, back to linear equations. So we have this as an example of a linear equation, 3x plus 12 equals 0. And we have this as an example of a linear equation, 3x minus 5 equals 4. Both of these are linear equations. And what do we know about linear functions? Well, the graph of a linear function is a line. Okay, so we can solve linear equations. And in this video, one of the things that I'm going to do is I'm going to show you how to solve linear equations. All right? So let's do that. So erase. Can I erase? No. Okay, so let's duplicate. All right, so let us consider this equation 3x minus 5 equals 4. It's a simple one to start off with. 3x minus 5 equals 4. So let's start off with that. All right. I wonder why this wouldn't go on presentation view. Okay, let's see. Okay, for some reason it would not go on. Okay, awesome. Okay, so let's look at this in the equation. It's 3x. Let me center that one. Let me center it more. Okay, so we have the equation. Let's get ready and let's do it. So we have the equation we have the equation 3x, right, minus 5 equals 4. And our objective is we are told that we are to what? Solve this equation, all right? Now when we say solve this equation, what do we mean, right? Well, what we mean when we say solve this equation is that we mean isolate the variable x, right? Isolate the variable x. What do you mean by isolate? We want to make x by itself, right? So we want to make sure that x is on one side of the equation and everything else is on the other side, and everything else is on the what? Is on the next side. So when we say solve the equation, when we say solve the linear equation, what we mean is we want to isolate x, make x by itself, all right? And x is going to be by itself on one side and everything else is going to be on the other side. Currently, x is not by itself. You say, Isaac, what do you mean? I'm going to show you right now. Notice that x is attached to a 3, right? So let's consider what I'm saying here. Notice, right, that we have this side of the equation. We call that one side, right? This is one side of the equation, and this is the other side of the equation. And notice, right? Notice that our x, right, is attached to what? It's attached to 3. And moreover, we also have what? Negative 5 there. All right? So x is on a side that has other stuff with it. And we don't want that. Right? We want x by itself. We want to isolate x. And that's what we mean when we say what? Solve the equation. So let's do that. We cannot use any willy-nilly methods to isolate x. We have to use principles of math, principles of algebra to ensure that we isolate x in the right way, and that's very important. So again, we cannot do it in the way that we feel like doing it. We must do it in a way such that the equation or the statement still makes sense. It's still balanced. All right? Okay, so let's do that. One of the things that we can do, right? One of the things that we can do in order to isolate x is that, notice, let's deal with the 5, right? Let's deal with this 5. So that 5 is a problem because the 5 is still on this side along with the x. And we need to get rid of that 5. So what we're going to do is we're going to send the 5 over the equal sign. All right? When we send the 5 over the equal sign, it changes from negative to positive. So we are left with, right? We are left with now 3x, right? Let me erase some things. And, okay, good. So now we are left with what? 3x, right, equals 4. Now we send the 5 over. So now that negative sign is going to be a positive, so it'll be what? Plus 5, right? You see that? And so now we have 4 plus 5 and we have 3x. So now what do? Right? We are going to consider this portion, right? What is 4 plus 5? Indeed, 4 plus 5 is what? We know that. That's 9, right? And then we write down 3x again. Okay, awesome. Now, again, we're not done because remember, our goal is to solve for x. Our goal is to isolate x. And currently, x is not isolated. X is not by itself because x still has this 3 attached to it. We don't want that. We want x to be by itself. And because 3x really means, right? And because 3x really means 3 times x, right? Because we have a multiplication going on here, we're going to do the opposite. So the opposite of multiplication is indeed what? Division. So we're going to divide by 3, okay? And whatever we do on one side, we must do on the opposite side, all right? It's like balancing an equation. Sorry, it's like balancing a scale or a weight, right? So if you have I don't know exactly what they call these stuff, but we're going to call it a scale or weight. So let's say you have one ball on one side and another ball on one side, and those balls are equal weight, right? If you go ahead and put another ball on this side, what begins to happen? Let's call it a seesaw. The seesaw becomes what? Uneven, right? So whatever you do on one side, in order to keep the equality, in order to balance the thing out, you must also do the other side. And that's the idea here. All right, so we divide both sides by 3. And what is 3 divided by 3? Indeed, 3 divided by 3 is 1. And so we're left with just x equals what? 9 over 3. But what is 9 over 3? 9 over 3 is indeed what? Is indeed 3. So are we done? Like, think about it. Really think about it. Are we finished? Are we complete? Is x isolated? Is x by itself? And indeed, x is by itself. X is isolated. X is on one side and everything else is on the other side. Therefore, we are done. We are completed. We have solved the equation. Now one may want to check if their answer is correct, right? So we got that x equals 3, right? So let us check and see if indeed that's the correct answer, right? We got a solution. We got x on one side and everything else on the other. That's good. But did we make a mistake somewhere? Like, did we, add wrong or subtract wrong? Did we do something wrong? And in order to one of the ways to check your work is to use your answer, right? Use your answer and substitute your answer into this equation. You say, Isaac, what do you mean? All right, let's dive into that. Let's dive into that some more. Okay, so we're going to what? We're going to be checking our work, right? So we're going to check our work. So we have the equation. 3x minus 5 equals what? Equals 4. It's important to understand what this is saying, right? This is interesting because what it's saying, this is actually making a statement. That's very important. Some persons don't understand that this is actually making a claim, right? This is actually making a claim. This is actually making a statement, right? This is actually what we call a mathematical sentence, right? It's making a declaration. It's saying declaration. It's saying that this quantity, right? That this quantity is equal to that quantity, right? That's a serious claim, right? That's saying that whatever this quantity is, it's going to be equal to that quantity. That is what's saying. That is the declaration. That is the statement, right? That is the claim. It's making a claim that one side is equal to the other side. Now remember, we are in the role of what? We're trying to check this thing, right? We're trying to check it. So we have to check if this claim is true, right? So this person wants to be important, and they make this bold claim. And so if you make the claim that one side is equal to the other side, and our claim is what? That this side is equal to this side, and we said that happens, that occurs when x is 3, right? And that's our claim right there. Our claim is that hey, given x equals to 3, I am certain that what? That this statement would be true. That this side would indeed be equal to that side. And that's our claim. But we have to check it. And how are we going to check it? We're going to substitute, right? We're going to substitute x into the equation and see if we indeed get 4, right? And that's our claim. So we have a left-hand side and we have a what? Right-hand side. And in order for the equation to be true, the left-hand side must be equal to the right-hand side. Okay, so let's consider the left-hand side, right? Let's consider the left-hand side. So left-hand side is 3x minus 5, but we know that x equals to 3, so 3 open bracket. We're not going to put x, we're going to put 3 because that's what x is, minus 5. Okay, and this is going to be what? 3 times 3 equals 9 minus 5. But what is 9 minus 5? Oh, 9 minus 5 is what? Look at that. 4. Does it remind you of something? Let's go to the right-hand side. Let's go to the right-hand side. The right-hand side is what? The right-hand side is, there's no calculations here. The right-hand side is 4, right? So we have that the right-hand side equals 4, and we have that the left-hand side equals 4. So what does that mean? That means, right? So let's write that down, right? Let's write that down. So the left-hand side equals to the right-hand side. And what does that mean? That means that what? We say that implies, this implies, right? That's the symbol we use for this implies in math. That means that what? That means that our answer is what? Is correct. Is correct. So that means that the answer we got, x equals to 3, is indeed correct. And we say that the solution set, the what? The solution set of this equation, right? We're going to call it a solution set S, contains what? Contains 3, right? That's the only number in the solution set, right? So that's our answer. And we solved our first linear equation. Okay, so let me go to the Facebook feed, because when I'm here screen sharing, I cannot see what's happening on Facebook. Maybe a comment came or something like that. All right, so let's see. Okay, so again, if you have any questions, if you are taking a math class, right? Math 167, Math 140, Math, what's the other ones? 168, 274. If you're taking these math classes, prep, whatever, and you have a question, I hope I'm not missing any comments, but if you have a question, put it in the comment section. I only see one comment so far. That's from Tim. Good evening to you too, Tim. I hope that's not. Okay, good. All right. If you have any questions, please don't hesitate to put it on, because we could stop. You can stop this what we're doing, and we can attend to your particular math question. All right. That's important. Okay. All right. If there are no math questions, I'm going to take the time to let you know a little bit myself. The name is Isaac, and I do math tutoring. All right. I do math tutoring for BJC, BGCSE, right? BGCSE and college math courses, right? So if you're interested in receiving some tutoring in those areas, do not hesitate to contact me at 428-8971. All right. With that being said, let's move on. So that was our first linear equation. Let us consider another linear equation. All right, let's consider another linear equation. Okay, so let's see what else the book has. All right, so notice that the book gives us this. I'm going to copy and I'm going to get this picture and put it on the PowerPoint slide, and then we can work with this question. So give me a moment to do that. So we're going to print screen that and place it on our slides here. All right. Crop it. And this may not look like a linear equation, but it actually is a linear equation. And the way we know it's a linear equation is because it's of the highest degree of every polynomial is 1. That's very important. Right? So it is a linear equation. You see, Isaac, what do you mean? Look at this. Look at it carefully. Let me bring that up. Look at it carefully, right? Look at it carefully. What's the degree, right? What's the degree of this of this polynomial here? What's the degree of that? What's the highest power on x? The highest power on x is what? Is 1. Notice that, right? It's not 0, right? And it's not 2. We don't have an x squared here. Neither do we have x cubed. We don't have those things in this sorry. Let me do it properly. I should be considering the whole side. So let's consider this entire side. Notice this entire side, right? And notice the x term. The highest power on x is what? Is 1. Even though we don't write it. We don't usually write it. But it's 1. So that's good. So at least we know that the first side is a linear expression. We look at the next side. What's the highest power on x? Look, the highest power on x is what? It's 1 again. Right? So indeed, this equation is a linear equation. All right? And we ought to solve this linear equation. And remember I said about solving linear equations. When you're solving linear equations, your job is your function is your purpose is, right? Or your goal rather is to isolate x, right? That's very important, and it becomes very important the more complex questions we do. Your job or your goal with these questions is that you want to isolate x. You want that x is on one side and everything else is on the other side. And currently we have some problems because x is on both sides. That's one problem. Another problem is that x is attached to different things. So this x is attached to this a half, and it's connected to this plus 5, and the x is tangled up, right? It's in a mess. And your job is to untangle it, right? And that's what we're going to do. But you have to use mathematical principles to do it. You cannot just say, I just want to put x here and just, okay, good, x is by itself. No. You have to use principles of math to do it. And that's what we're going to do right now. Right? So let's do that. So we have this equation. So we have a half x plus 5 minus 4 equals a third, 2x minus 1. Okay, notice that we can, okay, let's see how we're going to do this. We can notice that we have a fraction here, right? So we have a half and we have a third. And we don't like fractions. We want to have constants, like we want to have whole numbers. So let's as our first step, right? Let's try to get rid, right? Let's try to get rid of the fractions, all right? Let's try to get rid of the fractions as a first step, all right? Hope you don't mind, because it would be nice. Because if you get rid of your fractions, then, you get in familiar territory, right? Because some persons have problems with fractions. So let's eliminate our fractions as our first step. So how are we going to eliminate these fractions? So notice, right, notice the denominators of the fractions. The denominator of this fraction, a half, is 2. We know that. The denominator of this fraction, right, a third, is 3, right? So let's consider those denominators, and we're gonna find we carry back to grade 9, right? We carry back to grade 9, the LCM of those of those two numbers, right? The lowest common multiple. All right, so let's list the multiples of 2. The multiples of 2 is what? Right? 2, 4, 6, 8, 10, 12, and so on, right? And I should be clear. Let me just be honest and clear. These are not all the multiples of 2, right? This is just some of the multiples of 2, right? All right, so what are the multiples of 3, right? What are the multiples of 3, all right? What are the multiples of 3? So let's use the gray now. So the multiples of 3 are what? 3, 6, 9, 12, 15, and so on. Okay, so now what are some common multiples, right, between the two? Well, we know 6 and 6 are common between the two. We could see that. You see anything else in common? We see 12 and 12 is common. And there are other common multiples, but we're not looking for simply or merely common multiples. We're looking for the smallest common multiple, right? Now 12 could work, right? 12 could work, right? But we're not going to use 12 because that's not the smallest. So the LCM, and this is the notation that we use when you get into higher math classes, we say that the LCM of 2 and 3 is indeed 6. See that? So the LCM of 2 and 3 is 6. Awesome. So let me erase that. Okay, so erase. So we know that the LCM of 2 and 3 is 6. So Isaac, why did we go about trying to find the LCM? Because that is the number that we're going to multiply both sides by. All right? Okay, so let's erase that and erase that. All right? Okay, so let's do that. So we're going to multiply both sides. Notice what I'm going to do. And this is very important that you notice what I'm going to do. What color? Let us use purple, right? I'm going to put a bracket over this, and I'm going to put a bracket over that. Notice that I'm going to multiply the entire side of the equation by 6. Not just some of it, the whole thing. That means that every term that is, let me just use my laser. That means that every term on this side, this term, and the 4 will be multiplied by 6. Every term on this side will be multiplied by the 6, right? That's very important. Okay, let's do this. So we're going to multiply by 6. So here we have our 6 there. And notice that because of the way I wrote it, right? Maybe I should write that better because then you may get confused. So let me erase this. Sorry. Let me erase this and all right, let's do this. So we have 1 over 3 and we have 2x minus 1, and I'm going to use the purple to bracket off, and we're going to use the 6. Good. Awesome. So we multiply this entire side by 6 and this entire side by 6. That's very important. Okay, so what is a nice way to do this? All right. I think that what I should do is let's deal with the inside, because that would make things that would be a nice way to do it. Because if we start multiplying by, I mean, okay, okay. See, that's the thing. There are different ways, like some would say, there are multiple ways to skin the cat. All right. Um, there are multiple ways to skin the cat. Um, let's just do it this way. Right. Let's just do it this way. Right. So I'm going to multiply 6 by this term, and I'm going to multiply 6 by the negative 4. All right. So we have what? And watch the laser now. 6 times this term, right? And so let's do that. Let me just do that on the side here, right? So we have 6 times a half, right? X plus 5. How are we going to do that? Well, notice that all we need to do is multiply the 6 by the 1, right? And so we have what? 6 over 2 multiplied by x plus 5. And then we just have 6 divided by 2. What is 6 divided by 2? Indeed, 6 divided by 2 is 3. We know that. So now we have 3 open bracket x plus 5. So that's what we have for one of the terms. 3 open bracket x plus 5. And now we have, remember we said 6 is also going to be multiplied by the 4. So that means we have 6 times 4. Indeed, 6 times 4 is nothing else than what? 24. Awesome. So we have on this side 3x plus 5, 3 open bracket x plus 5, and 24. Right? So let's put that. So let's put that there. And notice, right? And that's very important. Notice that once we are finished multiplying by the 6, there is no more fractions. Let me show you. There's no more fractions. And that was our goal. We wanted to get rid of the fractions. So the 6 times the half gives us what? 3. We have open bracket what? Plus 5. Minus what? 6 times 4, which is what? 24. Alright? You see that? No more fractions. You see that? Look at that. Look at that. Look at this. No more fractions. You see how the 6 knocks out what? This a half. Right? And that was the idea. That's why we multiplied by the lowest common multiple. Awesome. So that's why, and that's very important. Oh, wow, man. Oh, man, it just completely erased everything. Wow. Wow, this is interesting. I'm so sorry. It just like, I shouldn't say it because I pressed the thing, but wow, this is interesting. But hopefully you see how, let's do this again. Hopefully you see how the 6 once we use the 6, the LCM, it really helped to what? To get rid of what? Of the fractions. And that's what we wanted to do. Right? So I gotta color code this thing again, so that's the power of one press. So hopefully those who didn't see it before is gonna see it again. And we have the 6 here, 6 here. Alright, awesome. And now we just have 6 times a half is 3, open bracket x plus 5 minus 24 equals. Now we're going to do the same thing. We're going to do the same thing with a 6 times a third. And that whole thing, notice. 6 times a third, open bracket 2x minus 1. Notice that we just multiply the 6 and the third. And that'll be what? Well, that'll be 6 over 3. Sorry, that's equal to 6 over 3, open bracket 2x minus 1. And what is 6 over 3? Indeed, 6 over 3 is what? 2. So that'll be what? 2, open bracket, 2x minus 1, right? So that's what we have. We have on this side 2, open bracket, 2x minus 1. Okay, so I got to be very careful not to erase everything, because then we'll have to start over. Okay, awesome. So what have we just done, right? What have we just done? We multiply the 6 by the 2 over 3, sorry, by the 1 over 3, and that expression there, and we get what? We get 2, make sure we have the right color. We have 2, open bracket, 2x minus 1. Look at that. Look at that now. What do we have? An expression with no fractions. We don't have no fractions here, right? And that's what we wanted to do. Now it should look, or it may look familiar now to you. And if it don't, now we're gonna use a little bit more math to simplify it even more. Okay, so let's do this. We have 3 times x, right? We're gonna multiply the 3 by the x. We call that distribution. We multiply the 3 by the x, and we're gonna multiply the 3 by the 5, right? And so that'll give us what? 3x, right? 3x plus, what is 3 times 5? Indeed, 3 times 5 is nothing else than what? 15 minus 24. Awesome. Good. Let's do the same thing for the other side. So we have, all right, so color. Okay, good. So we have 2 times what? 2x. 2 times 2x. And 2 times 2x is nothing else than what? 4x, because you have 2 times the 2. You care about the coefficients. So we have 2 times 2. Let me use my laser. 2 times 2, which is 4. And don't forget the x. So we have 4x. Oh, let's use red. So we have 4x. 4x. Oh man, I want to use red. Okay, so we have 4x. Make sure we have red. So we have 4x minus what is 2 times 1? 2 times 1 is indeed 2. So we have what? We have 2. Okay, good. So it's simplified further, but we're not completely done. Why are we not completely done? Because we have x on this side and x on that side. We don't want that. We want x to be by itself. We want to isolate x. We want x on one side and everything else on the other side. So we have to deal with that. Okay, so our preference is to make x on the right. That's our preference. We could also do it, but try to put x on the left. The same thing will work. But our preference is to have it on the left. I mean, to have it on the left. Why did I say? I hope I didn't say right. And if I did, I was wrong. Our preference is to have it on the left side. We could also have it on the right, but we don't usually do that. At least we can do it. I shouldn't say we don't usually do it, but I just say most times when we bring it down, x is usually on the left side. Okay, so that's what we're gonna do. We're gonna put x on the left side. And okay, so all these other stuff, like the 15 minus 24 or whatever, they gotta go to the other side. All right, and everything with x in it gotta go on this side. The good thing is we already have 3x here, so that's good. But before we even send this over, right, instead of sending it over one by one, let's just simplify it, right? So because 15 and 24 are like terms, so let's just simplify it. Okay, so we have 15 minus 24. 15 minus 24. What is that? All right, now there's different ways to do it. Or if you don't want to encounter that whole situation, maybe it would be best to, if you have a challenge with dealing with negative numbers, maybe it'd be best to send it over right now. Alright, so let's do that. You're going to send it over. Contrary to what I said to previously, you're going to send it over. And so we have 3x equals 4x minus 2. Now we're going to change this sign. It was a positive. It's going to be a negative now. And this is what? It was a negative, now it's going to be a positive. So we have plus 24 minus 15. Okay, good. So we have 3x equals 4x minus 2 plus 24 minus 15. let's consider this, these whole numbers, right? Like what is that? What is that? Like what is that? I said whole numbers. I mean, I should said integers. What is this expression equal to? So let's see. So let's first consider 24 minus 15, right? Let's do that first. What is 24 minus 15, right? Indeed, 24 minus 15. We're gonna do this manually. 24 minus 15. All right. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's 9. That's 9, right? That makes sense. And then we have 1. So what is 1 minus 1? Indeed, it's 0. So 24 minus 5 is 9. Sorry, 24 minus 15 is 9. And notice that we also have what? The negative 2. So we have to have what? 9 minus 2, right? What is 9 minus 2? 9 minus 2 is indeed 7. So this whole expression here, right? You can put in your calculator if you want. You could say negative 2 plus 24 minus 15. But it'll give you 7, right? So let's indicate that here. All right. Right, so let's indicate that here. I'm gonna erase it because I'm running out of space. So it's gonna be what? It's going to be plus 7. All right. So we have what? Plus 7. Sorry, I really want the red instead. So we have what? Plus 7. Good. Are we done though? Are we done? The answer is no, because x is not isolated. X is still, we still have x on one side and x on another side, and we don't want that. So we're going to what? We're going to send this 4x over the equal sign. So we have what? Okay, we have what? We have 3x. Let's use this red one. We have 3x minus 4 equals what? Equals 7. Alright? And what is 3x minus 4x? Right? What is 3x minus 4x? Well, that's what? That's negative x, right? Because think about it. If you have $3 and you owe someone 4, right? And then you pay them back, and you pay them the $3, and you pay them the $3 that you have. Well, how much you owe them? Well, you owe them $1 more. So since you owe them $1 more, the answer is negative 1. So let me erase that and put negative x. So we have negative x here, negative x. Awesome. We're almost done. You say, Isaac, why you say we're almost done? Aren't we done? Isn't x on one side and everything else on the other side? Not quite. Because we still have this coefficient, right? And even though I just put negative x, right? And even though I just put negative in front of it, that's really a number, you know. That's negative 1, right? That's negative 1 right there. So we still have a coefficient. So we still have something attached to our x. We don't want that. We want x to be by itself. So in order to do that, in order to, you know, make things better, in order to completely isolate x, we're going to divide both sides by what? By negative 1. So we're going to divide both sides by negative 1. Dividing both sides by negative 1, the negative and negative cancel out, and we have x equals, what is 7 over negative 1? Well, that's indeed negative 7, right? So the answer that we receive is negative 7. And now we're done. Now we're done. That was a long explanation. But now we're done. X is equal to negative 7. And that's our solution, right? And so in our solution set, we have negative 7. So I got negative 7. Let's see what the book got. Hopefully we did it the right way and we didn't make any mistakes. All right. So let's look at the answer that the book gave. So let's see. So just like we did, what did they do? They multiply both sides by what? Let me use my cursor. They multiply both sides by what? By the LCM of 2 and 3. That's exactly what we did. And then of course they what? distributed, use associative property, and so on. And then they what? They what? Combine like terms and so on. And the answer that they got is what? -7. And when they did the checking, what happened? Indeed, both sides, the left hand side and the right hand side, had the same number. So the left hand side is -5 and the right hand side is -5. So that means that what? In the solution set, we have -7. Okay, so that brings us to the second linear equation that we have done for this time. Let me check the messages on Facebook and see if we have any. Thank you. I see something from Keisha Sands. Thank you so much for commenting. This definitely helped me. Awesome. 12, 6. Oh, okay. Shantavia Martin, say, where were you in one? Wow, that's interesting, right? Okay, so the 6 doesn't multiply to 5. Look at awesome. All right, thank you so much for the comments. Again, if you need math assistance, or if you know someone who need help with tutoring for primary school tutoring, secondary school tutoring, college tutoring, and even adult tutoring, please don't hesitate to consider contacting me at 428-8971, and hopefully we can arrange something. Thank you so much for your participation. If there is some question that you need to be answered, that you need some help with, you can post it on Facebook or post it under the same link or whatever, and tag me in it or something like that, and then we'll consider. Once I see it, I'll try to make an effort to see if I can answer that question for you, and hopefully give you an understanding of how to go about thinking about the question. All right. So if that's it, we can call it a wrap there. Thank you so much for your time. Again, in this presentation, we looked at linear equations, right? We looked at linear equations. We saw we saw the definition of linear equations. We saw how to solve linear equations. And we saw a simple one and a little more complex one involving what? Involving finding the LCM, involving fractions and stuff like that. And we also learned how to check if our solution is correct. So hopefully this helps, and thank you so much for your time and attention, and we'll see you in the next video.